All right. Hi, everyone. Welcome to the last session of the summit. Thanks for sticking around to the very end. We just have closing remarks after this. This panel session is titled Methane Reduction, Capability Building, and Cow Care. And the group here is made up of researchers who produced a poster and a short video of their research for the summit. There is one caveat, though. Our researcher whose project was focused on capability building was unable to make it. So the focus today is now going to be solely on methane reduction and cow care research, but mostly on methane reduction. I am your moderator. My name is Kevin Comerford. I am the Chief Science Officer at the California Dairy Research Foundation, more commonly known as CDRF. We are a nonprofit organization and primarily funded by CMAB, the California Milk Advisory Board, with California producer checkoff dollars. And for the sake of full disclosure, I'd like to say that a few of the research projects that you're going to hear about in this session were funded by CDRF, and that's actually something that we are quite proud of. Just a quick bit of background. In our call for posters, we had 7 different sustainability topics that we were interested in hearing about from researchers. But overwhelmingly, we received submissions focused on 2 topics: manure management, which was just covered in the last session, and methane reduction, which is covered in this section. So those are 2 of the really hot sustainability topics that we're dealing with in California, as I'm sure you're all very well aware, especially if you've been paying attention over the last couple of days. For this session, we have 5 researchers. Hopefully, I think they're all here with us at this point. They're all coming from either UC Davis or Riverside, and I want to thank them all for being here today. I'm going to give them a few minutes to briefly introduce themselves, but just to provide you with who they are right now, we have Valerie Carranza from the University of California, Riverside, Angelica Carrasco from UC Davis, Connor McCabe, also from UC Davis, Francesca Hopkins from the University of Riverside as well, and Yingwei Li from the University of California, Davis. And we do want our audience to participate as much as possible in the Q&A, so we encourage you to ask questions. You can do this through the live Q&A button on your screen. You'll type these questions in, and they will find their way to me. And now for the introductions, we will start with Valerie, and we'll go to Angelica, Connor, Francesca, and Yingwei in that order. So Valerie, would you please kick this off and introduce yourself and your research?
Hi, good afternoon. My name is Valerie Carranza. I am a PhD candidate at the University of California, Riverside. My research project that I'll be talking about today was on isotopic signatures of methane emissions from California dairy farms in the San Joaquin Valley. And the main takeaway was that we found that there were more enriched isotopic signatures from manure management compared to enteric fermentation. And we saw that also from downwind plume sampling of other dairy farms.
Right, then thank you. And we're on to the next one. So can you please introduce yourself, Angelica?
Hi everyone, my name is Angelica Carrasco. I'm a PhD candidate at UC Davis in animal biology, and research focuses on methane reduction strategies in terms of enteric and manure management. And so the research that I am talking about today is a project which I recently completed, which focuses on enteric methane reductions using feed additives, more specifically tannins and saponin blends. So our large takeaway with that was that we tended to see reductions in methane production, which is very exciting. There's still some ongoing work with that, but very excited to talk a little bit more about that today.
Okay. All right, thank you very much. And now moving on to Connor.
Hello everyone out there. My name is Connor McCabe, and I'm a PhD student at UC Davis. The research poster that I put together was on the California dairy industry's timelines to reach climate neutrality. We looked at various scenarios based on greenhouse gas emissions from California dairies, from manure management to enteric fermentation, or methane produced by cattle burps. And the various scenarios we looked at were keeping everything constant through business as usual through 2030, reducing methane by 40% to reach the Senate Bill 1383 goals by 2030, as well as a reduction of the manure methane along with reduction in enteric based on feed additives. Based on looking at the production of greenhouse gases and the net warming of those greenhouse gases, we saw that it may be possible, if there's consistent strong reductions in methane emissions in the years to come, for the California dairy industry to reach climate neutrality by the year 2027.
All right, thank you very much. Francesca.
I'm a professor at UC Riverside, and the research that I'm showing here is where we came up with a methane emissions baseline for each dairy farm in California. We did this by combining information from permit data with emissions that we can estimate per cow from each farm, and we developed a spatial map that shows how much we think each farm is emitting right now in terms of enteric and manure emissions across the state. And we saw that different regions of the state have very different emissions profiles. Specifically, the amount of enteric to manure methane produced differs in different regions of the state. And this baseline is really critical to have in order to measure future reductions in greenhouse gases against this baseline that we developed at the farm scale.
All right, thank you. And Ying Wei.
Oh, hi. I'm Jinghui Li from University of California, Davis, a postdoc, and my research is mainly on mathematical modeling in animal science. So today for the summit, I presented my research, optimized controls for cooling dairy cows. So in this project, we integrated a thermal balance model and a spray cooling model. So by doing this, we can quantify the heat transfer mechanisms and the temperature of the animal. And then we can develop an advanced controller to optimize the sprayer and the fan to provide adequate cooling while minimizing the electricity and water usage.
All right, so let's get into some questions. I will start off since I don't see any coming through yet from our audience, but please do send some questions in if you're out there paying attention still. Let's start in reverse order. We'll just start with Jingwei, since you are actually the outlier here, and that your video was focused on cow care, animal health, more so, where everybody else seemed to do more on kind of methane modeling and measurements. So for your model, your video and your poster showed you combining these two models together to optimize cow cooling. Sounds like there's some water use, energy use, benefits to that as well. So my question to you would be, in addition to the water and energy, why is improving cow cooling, an important sustainability issue for California dairy? Is there some benefits, to a cooler cow? Does that produce more milk? Do they have less health issues? Better fertility? Can you kind of go on and tell us more about why cooling cows is important for California dairy sustainability?
Oh, sure. So as we know, in most areas in California, we have a hot summer. And the cows are susceptible to heat. So in summer, they are very likely to get heat stress without any cooling strategies. So heat stress will bring milk production decrease, and also it will undermine the immune system and also reproduction system. So what we are going to do is trying to avoid this, and by applying cooling strategies, so we can cool the cow down to maintain the production and also the overall health. And our model can guide the usage of the application of cooling, so that we can save electricity, of course. And California is also in shortage of water in some areas, so we also want to save water while cooling down the animal.
Okay. Can you also talk economics a little bit, like how how much is the investment cost to start using a new model like this? Does a producer need to, buy new controllers and sprinklers, or can they just kind of tweak their current, system?
Yeah, so basically they don't need to change the sprinkler and the fans they are currently using. All they need is a gateway that controls the fans and the sprinkler, and also several sensors to monitor the climate conditions, like including temperature, humidity, and wind speed. So based on our estimation, a gateway along with several monitors is going to cost about $1,300 per bond. And for each bond, there might contain about each bond there should be around 300 to 600 cows. So that's our estimation. And also, if you use this system, the electricity, we only calculate the electricity usage. Compared to without the system, we can save up to $4,000 annually for electricity alone. So it will take about 2 to 3 years to get all the payback.
Okay, so it sounds like a good investment, though.
Yeah, definitely.
All right. Okay, let's move around a little bit. Go to Francesca, Dr. Hopkins. Your project looked at, methane emissions at the farm scale, which you mentioned is really important. And, so why is knowing the specific kind of regional differences, the facility level differences of where the methane is being emitted, why is that important for mitigation efforts? You mentioned it being, something that we need to know. So can you tell us more about that?
Yes, thank you. Great question, Kevin. We really think the facility scale is the fundamental one because that's the scale at which implementation of mitigation strategies is taking place. For example, right now, anaerobic digestion is the state's main strategy to reduce methane emissions, and anaerobic digesters are installed at the individual farm level. So it's really important for us to have a baseline for the emissions, what we'd expect them to be based on the herd size before the digester is installed. So then we can actually verify after the digester is in place that we see the emission reduction that we expect. You also mentioned in your question about regional differences, and that's something that we looked at very carefully. There are regional differences in climate and management practices across the state. And those differences lead to differences in the emission profile. So, for example, dairies on the North Coast have much more proportionally of their methane emissions from enteric sources versus manure compared to dairies in the San Joaquin Valley because of how manure is handled. And so, if you're thinking about mitigating methane emissions, if you're a North Coast dairy, it probably makes more sense to invest in reductions at the enteric side. But if you're in the San Joaquin Valley, it would probably be more effective to go after manure.
Yeah, those are some pretty key differences. So talking a little bit more about the digesters, you had some data in your video showing that there was a little over 5% methane reduction in state totals from digesters. Can you tell us a little bit more about that? Is 5% a good number? Is that a number that you expected to see before you ran this study?
Yeah, that's another good question. So it's not dissimilar to what CARB has already projected the impact of digesters to have on the state's methane budget. However, as CARB has recently reported themselves in a report that they issued last week, it's not enough to reach the state greenhouse gas reduction targets. So it's important that we think about other strategies, implementing other strategies in addition to the digesters that are already there. I also want to point out that our study only included the digesters that were funded up through 2019. And so there's continued to be investment in digesters after that we haven't accounted for. One other point that's, I think, really important to consider is that we really want to ensure the state is meeting its emission reduction goals. And by having this baseline number, we can actually interrogate whether our systems to verify emissions are going to be capable of detecting these differences. So now we have a number that we can compare to the statewide observing system to actually see whether it's possible to detect differences of this magnitude in the statewide network.
Awesome. Okay, so we have kind of two other research presentations that are pretty connected to what you're doing. One with Valerie, I think you work with, and also with Connor. We'll start with Connor because he's doing some modeling and also talking about, digesters and, how effective they can be. So Connor, we'll move over to you. And thank you very much, Dr. Hopkins, for your answers. So Connor, your poster and video were focused on California's timeline for reaching climate neutrality. And I mean, do you think climate neutrality is kind of the ideal end goal for California? Is that, the benchmark we should be working towards? Or do you have some other, opinions on where we should be going in the next couple of years?
Yep. Thank you for the question on that, Kevin. So I want to say climate neutrality, of course, is no net change in the warming of the greenhouse gases produced year upon year. And by reducing methane in the short term, we can have, given methane's short life, more methane removed from the atmosphere than produced. And this can help offset emissions from other areas such as feed production or nitrous oxide emissions dealing with manure management. Climate neutrality in the short term, I think, is a great goal for us to have in terms of we can say that the California dairy industry is contributing no net warming to the atmosphere at this given point. But every year we're going to have to continue to look to reduce methane emissions, continue on this pathway of contributing net zero warming to the atmosphere. And it's going to have to be a case by case basis. I don't think that net zero emissions, absolutely zero emissions, is a goal that maybe is the most tangible to reach after. But based on reducing methane in the short term, there is the strong ability to be able to achieve this climate neutrality goal. And based on levels of adoption for these various methane management technologies in the years currently and going forward, could look to further reduce the industry's emissions towards that warming of the atmosphere, and even pull and reduce and offset previous emissions that it's contributed to atmospheric warming.
Okay, thank you. And in your modeling, you kind of compared two different scenarios to, the business as usual approach. You looked at, one scenario with a 40%, manure methane reduction, another scenario with 40% manure reduction, and a little over 11% enteric reduction. And it looked like in both models, we, appear to hit climate neutrality or even climate, negative by 2027. So, how reasonable are these scenarios? Are there, potential ways to get there even sooner than 2027? Or is 2027 kind of the best possible model we can hope for?
Certainly. Thank you for that question there. As Dr. Hopkins alluded in those previous answers, I know she's mentioned the CARB report coming out last week, showing that the state is approximately halfway towards that 2030 goal based on digester projects that have been currently funded and are being built and should be reducing those methane emissions out there. And currently looking at the projections that CDFA has available and CARB has available, the dairy industry is currently continuing on this same pathway that we projected out, at least looking through the year 2023. So given that there's been vast reductions in methane based on a strong policy behind the dairy digester research program, I think that if we only are going to achieve this if we continue on this aggressive pathway that we're on now, and any backing off of that is going to further extend out the timelines we have projected here of when climate neutrality may be first reached for California dairy, and therefore should look at continuing those investments to help the industry as an overall lower its impact, not just for the industry itself, but for California as a state.
All right, thank you for that. Now I'm going to move over to Valerie, who's also looking at some methane emissions from dairy farms in the SJV. She's looking at kind of isotopic signatures or isotopic signatures. And can you just tell us a little bit more about why that's an important method, Valerie? And then we'll go into some additional questions.
Yes, yes, of course. So I think that stable carbon isotope measurements of methane are important because it could be a valuable source apportionment technique to help us distinguish between enteric and manure methane. Before the study, there hasn't been a lot of work done in the San Joaquin Valley, where most of the dairy farms are located. And that's where we would expect most methane emissions to be coming from. Some work has been done in the Los Angeles basin, but more work needed to be done in the San Joaquin Valley. And the reason being is that this could especially be useful tool to monitor and quantify enteric to manure ratios, especially with changes in mitigation, changes with where there's installation of digesters, as Dr. Hopkins mentioned, and whether these tools are working. And one way to do that is to measure using isotopic measurements, where we can measure downwind of these dairy farms and could tell us whether it's mainly coming from enteric versus manure methane emissions.
And you did these measurements kind of throughout the whole year or over the different seasons. Can you tell us maybe how these measurements change or these ratios change with season? Is that an important factor?
Right, yes. So for this study, we measured during different seasons, and this is important to tell us whether these isotopic measurements are consistent throughout and whether we see these differences between manure and enteric methane emissions. And what we did find was that throughout all these seasons, we consistently see that manure methane emissions are more enriched in the isotopic signature of methane compared to enteric fermentation sources. We also see that for enteric fermentation sources, there are some slight differences within different seasons. And that mainly has to do with what we found has to do with the composition of the feed and how that changes throughout these seasons, whether they're fed more of a C4 versus a C3 diet. Over time, it's important to measure this to ensure that this is still consistent throughout, and that we still see these differences that we could be using enteric versus manure methane emissions.
So you could see the differences between C3 and C4 in enteric, but those don't show up in manure. So the diet doesn't seem to affect manure. There's just too many more variables, microbes, things going on there.
Yeah, it's a great question. So there were some subtle differences in these manure isotopic signatures between seasons, but it wasn't as stark as what we saw from enteric fermentation. So although we do think that there might be some influence from the diet composition from one season to the other, whether they are fed a C3 versus a C4 diet. Other differences that might be influencing that is things like substrate depletion, or whether there are other changes in the lagoon, like mechanical removal of solids, or a combination of these factors. But more measurements are needed to really confirm this. More measurements of isotopic signatures, both from methane and also ideally also from carbon dioxide isotopic measurements, because that could tell us more about the microbial and biogeochemical processes that are driving these methane emissions from manure lagoons.
Thank you for that. So now we'll move to Angelica. So we talked a little bit about diet and methane. So she did some work looking at administering, feed additives with tannins and saponins on methane emissions in lactating dairy cows. And I see, Angelica, that your data were provided kind of as averages over the 6-week trial. Is 6 weeks kind of the the minimum time it takes to see results for a feed additive like this? Or do maybe some cows, see benefits at 3 weeks, 4 weeks? Can you talk about that a little bit?
Yeah, that's a great question. So I have dug a little bit deeper into the specifics in terms of the weeks. I did have 4 different sample points with my animals, testing them every 16 days. And so I did have some glimpse into that shorter time frame. We were mostly interested in seeing if there would be any differences at all with inclusion of the additive at the dosage that we had supplemented it. But in digging a little bit deeper, we do see that there are differences beginning around day 32 is when we start to see those differences between our control treatment and our tannin feed additive treatment. So don't know too much about the long term, as it was a shorter term trial that we conducted, but we do start to see those differences about the 32 days into the trial experimentation.
Okay, and is this an additive that, you just tested it on lactating cows? Is this something that, a producer might feed all of their animals, or just the lactating ones?
Yeah, so that's a great question. I think in terms of what the animal's consuming, you would expect to see more pronounced differences if you are feeding your animals a higher forage diet. And so that might be something that would be lucrative to a producer if they have their heifers on a higher forage diet than their lactating dairy cows, as is generally expected. Then that might be a point where they could implement feed additives earlier on. I think really the draw is with the lactating dairy cows, as those are your productive animals. And so producers oftentimes think to those animals before thinking about others. However, we have seen, not in my lab, but with similar additives, reductions in beef cattle as well. And so I know that this is something that can be implemented with other forms of cattle livestock as well.
All right, thank you. And then I just have a couple more minutes here. I'm going to go to some questions from the audience. We have one here that I think I will direct towards Francesca or Valerie, either one. What are some of the reasons for big differences in methane production across regions? Things you see that we can learn from the low methane producing regions?
I can take this because the study was really focused on looking across all the regions. And I think really it's the differences in manure management that make a very, very big difference. And so any time spent where the cows are spending on concrete is when their manure gets pushed into lagoons and has high potential to generate methane. And anytime the cows are standing on other surfaces, including pasture or corral, there's much less potential for their waste to produce methane. So it's really regional differences in how much time animals are spending on concrete in freestall barns that's driving the regional differences primarily. There are some climatic effects, but they're much, much smaller.
All right, thank you for that. And I think I have time for one more question, and it's going to be sent to Connor. And this is, when do you anticipate the California dairy will actually achieve climate neutrality? And what are the most important factors in this timeline?
Yes, so in our model projections, we saw that potentially 2027 would be the year that we would look at first achieving climate neutrality. The most important part of this, of course, is the methane emissions associated with dairy, approximately 60 to 70% in there. Emissions are associated with dairy, with methane, and given methane's short lifespan, if we can reduce methane in the short term and have the same amount removed from the atmosphere, that's going to lead to great reductions in the warming impact of those greenhouse gases. And so reducing methane emissions from manure management, as is currently being done through the building of digesters, is going to be the best way to help drastically reduce the warming impact of the California dairy industry.
All right, thank you for that information. Thank you all. We're going to close out this session and invite you all to stick around for the closing remarks coming up next. Once again, thank you, and thank you.